Hi everyone, this is Friday, December 1st, and today we're gonna talk about session 7.2, substitution. And then today you also have homework 10 is due, right everybody? So remember you submit your first attempt by midnight, and then after midnight you can still go in and continue to work on the homework to improve your scores, right? And we have 11 homework. We drop the two lowest. So if you have been getting 9 perfect scores on your homework, you don't have to submit homework 10 and 11. But if you want to do well on the final, you need those practice, right everybody? Yes, so that's the homework, and I just give you the exam back, and then this is the scores. You know what, I'm so surprised, like you guys did really well. Because remember I told you I think this exam is harder, right? Because it's application problems. Usually students don't do well on the application problems. Sorry, I forgot to project my screen. Alright. Okay. Where is okay. And then this one here. Okay, let me see. My recording still okay? Alright, yes. Everybody able to see the scores? So exam 4, the highest score is 97. Good job. The lowest score is 57. The average is 80.33. Yeah, I thought exam 4 is harder than exam 3, but you guys actually did better than exam 3. So good job. We have 2 students get A, 1 student get B, and 5 students get C, and 1 student didn't do well. Okay, but this is much better than I expect. Okay, so if you don't do well on one exam, remember you can use the final exam score to replace one lowest chapter exam scores. Okay, so we only have 1 week left. We try your best, and I think maybe start reviewing the old concepts because your final exam covers everything, right? And then the practice final exam is already on the website. So you can start reviewing from the first week and then do the practice final exams. If you have questions, ask me. And besides the practice question? Okay, our final exam is actually on Monday, 10 to 12. Okay, so after the next week, you only have the weekend to study for the final. The final is pretty early, Monday. Do you have other exams on Monday?
I guess so.
Yeah. How many?
I think all of them are on Monday.
All of them?
It's close to all of them. At least 3 of them are.
Oh no, that's so bad. Don't you pick up your exam?
But I think one we don't actually have to be there for class.
Oh,
Yeah.
Good luck with that. Okay. Yes, you know how to find the final exam schedule, right? Do you? Yes. So go to the website and then here, final exams, and then you can search the course and find a final exam schedule. All right. And then let's see. Okay, yes. So besides the practice exams, and if you go to homework, you see the final exam review. Yeah, this is optional. Okay, it kind of like collects all the homework that some of the homework exercise and create this final exam review. You know the homework, if you get the problem right, when you go in, it won't generate a new problem, right? So you can practice this final exam review. This is optional. So you have practice exam and then this one. Okay. The practice exam, you need to turn those in, but this one is optional. So do you receive my email if some of you miss some homework, miss some practice exam, miss some exam correction and wrapper? Please turn those in. Gabby, here your exam. Okay. Please turn those in as soon as possible. The last day I accept late work is next Friday. But you don't want to submit your work on the last day because if you submit earlier, if I see you miss something, I can let you know and then you can resubmit to get the points back. For example, some students only turn in the exam wrapper, not the exam correction, then the student only get 5 points. So if you turn those in earlier, I can let you know there's something you can fix to earn the points. So don't turn in your work like the last day, because then you don't have time to fix your work. Okay, so and also the extra credits. Next week, show me your notes. So if you have been taking your notes, next week show me your notes. So you can either come to my office. I have office hours from 1 to 1:50 and also 3:15 to 4:15. So you can Monday, Wednesday, Friday. And then Tuesday, Thursday is from 11 to 12. Okay, so or you just walk by my office. If you see I'm there, just come in and show me your notes. It just take me maybe 5 minutes to just go through your notes and make sure you don't miss any example. Because if you miss one example, you will lose point 1. So if you miss a class, make sure you go to the lecture videos and also I have the notes with answers online, right? So fill in the notes. Okay, the note bonus is 1%. And if you miss no more than 2 classes, okay, that you also get attendance bonus 1%. And have you helped me to fill the class evaluation? If yes, so please do it. If the overall response rate is greater or equal to 90%, then everybody will get 0.5% extra credits. Okay, so that is what? 2.5. And if you came to the international meet and greet, you also get 0.3%, so you can get at most 2.8%. Okay? Hopefully, that might help you to raise 1 grade. Okay, so any questions so far? Good. Let's continue. So last time we talked about antiderivative and even acceleration. We can integrate the acceleration to get the velocity, right? But when we integrate, we get a family of antiderivatives. So we have the plus c. We need some initial conditions. Sometimes the problem may give you initial velocity, then you can plug in and find the number c. And then you integrate the velocity, that will give you displacement. And after we integrate, we also get another constant, d. And then usually the problem gives you initial displacement. You can then plug in and find the d. Right, everybody? Last time we did this example, right? We have acceleration, we integrate, we get velocity, plug in the initial velocity, and integrate, we get the position function. So, and then we also did example 6, right? We were given the rates of change of the population. And in order to get the population, we integrate the rate of change, then we get the population. All right. And this is what we got. And we haven't finished. So part A, we plug in t equals to 10 in the rate of change. And then we get negative 92. It means the number of the population decreases because it's negative, by 92 at day 10, okay, the 10th day. And then part B, find P of t. So we integrate the rate of change. And do you still remember that paper? I asked you to, what is that? The antiderivative formula. You have the derivative formula and the antiderivative formula, right? So yeah, keep this paper. You can also make some copies and tape it around your room so you can review the formula every day. Okay, so if we have e to the kx, the integral is e to the kx over k. So therefore, the integral of e to the negative 1 over 10t, the minus 250 remains here because constant multiple just stay here. And then this is e to the kt over k. The negative cancel. And when you divide it by 1 over 10, it's the same as multiply by its reciprocal, which is 10. So 250 times 10 is 2500. And then e to the negative 1 over 10t plus c. Okay, we have plus c. So we need to figure out what is c. And let's see the problem. The problem tells us that when t equals to 0, the population is 3,750. So this is the initial population. So we can plug in. So P of 0, we plug in T is 0, is 3,750. And then you plug in this function. We get 2,500 e to the, because you plug in t is 0, so negative 1 over 10 times 0 is just 0, right? The exponent is 0. And then plus c. Right, everybody? Okay, what is e to the 0? 1. Oh, how do we solve for c? So c is both sides subtract 2500. Yeah, everybody? Yeah, what's the answer? Huh? What? Yeah, yes, 1250. Yeah, very good. So this is the c. Therefore, p of t is, always write it down the function p of t. After you find the c, plug it in. So this is 2500 e to the negative 1 over 10t plus c. c is 1250. Yes, everybody? Okay, this is p of t. And then let's continue. Part C. What is the population after 15 days? Okay, 15 days. We plug in t is 15. Right, everybody? We have the population function. We want to find the population after 15 days. So we plug in t as 15. Let's see. So 2500 e to the negative 15 over 10 plus 1250. What do you get? Anyone has a calculator? Yeah, please practice using your calculator. Because sometimes I do have students ask me, how do I do this in the calculator during the exam? During the exam, I cannot answer this question. During the exam, I can only answer questions about this question. If you don't understand the problem, I can explain to you, but I'm not supposed to teach you what to do. So yeah, everybody practice using your calculator. Thank you. Right, everybody? Good. So this is part C. And then part D. According to this model, how long will it take for the trial population to reach 1500? Exactly. Very good. So we find T such that the population 2500 e to the negative 1 over 10 t plus 250, plus 1250 equals to 1500. Okay, we want to solve for t. What do we do? Yeah, minus the 1250. So we get 2500 e to the minus 1 over 10 t is, what's that? 250. Then what do we do? Yeah, very good. Divide by 2500. So when you solve equations involving exponential expressions, you want to isolate the exponential expression. Isolate means you only want to have this exponential expression on one side by itself. All the other numbers should move to the right hand side. That's why we move this constant to the right hand side, and then we divide it by this multiple. So the left hand side, we get e to the negative 1 over 10 t. The right hand side. Oh, do you see the right hand side? We just get 1 over 10. Yeah? Okay. After you isolate the exponential expression, to get rid of the e, what do? Apply ln. We apply ln on both sides. Okay, so natural log and exponential function, they are inverse function. So we apply natural log on both sides. Okay, we apply natural log on both sides. And then natural log and e cancel. We have minus 1 over 10. T is natural log of 1 over 10. Then t is, do you see? We both sides multiply by negative 10. Yeah? Both sides multiply by negative 10. Question. Can I cancel this 10 with this 10? No. The 1 over 10 is inside the natural log. It's not multiplication. It's natural log of 1 over 10. Okay, so it cannot cancel. So put this in your calculator. What do you get? How many days? Yeah, after that, we'll do this. So minus 10 times natural log, parentheses, 1, what? 23, thank you. Yes. So it takes 23 days for the population to reach 1,500. Questions? The process, how do we get negative 10? Oh, this one? Oh, natural log and e cancel. So when you apply natural log on both sides, they cancel. Then you only left with minus 1 over 10. So it's inverse function. Remember, like, how do you get, if you have x cubed equals 27? Then you both sides apply cube roots, right? And if you have like e to the 5x equals 2, then you apply ln on both sides. Then we cancel, you just get 5x, right? And if you get ln of 5x plus 1 equals 3. What do? You both sides raised to the power of e. Then e and ln cancel. You get 5x plus 1 is e cubed. So it's whatever you want to carry on that, apply the English function. Okay, so this is example 6. Any questions about example 6? All good? All right, let's look at example 7. So we have a ball that's thrown upward with a speed of 48 feet per second from the edge of a cliff. Okay, so we have the cliff, you're right here, and you throw the ball upwards, 48 feet per second. Let's say the upward direction is the positive direction. And then the ball will go out and then hit the ground, right? And this cliff is 432 feet above the ground. Find its height above the ground t seconds later. All right. And when does, okay, so question 1. Find its height above the ground t seconds later. And second question, when does it reach its maximum height? And then what is the maximum height? So did you learn like physics before? Do you know the acceleration due to gravity is 9.8 meters per second square, or it's 32 feet per second square? It's actually 32.2, but to make the calculation easier, we just use 32. Okay, so and you know the acceleration due to gravity is because of the gravitational force, which is down, right? Okay, so therefore the acceleration a of t is the same as g of t. If we set the upward direction is the positive direction, then the acceleration is going down because it's the attraction from the earth, and it's minus, in this case we're using feet system instead of meters, so we use the 32. Is that okay, everybody? All right, let's see, this is acceleration, and now we find the velocity is integral of acceleration. Okay, remember every time you write integral, it's 3 parts. It has s, and then we have the function, and we have the dt. Okay, everybody? So we must have 3 parts. So what's integral of negative 32? Dylan, what is the integral of negative 32? Yes. And then plus c. Yes. So after you integrate, don't put the integral sign anymore. Because if you put the integral sign, you're like, oh, you're like finding the integral and the integral. So you find the integral twice. So don't do that. After you integrate it, don't put the integral sign anymore. And you have plus c. And here we have initial velocity. Right? The initial velocity, because we throw the ball outwards, we have V0 is 48, and it's positive 48 because it's outward. And we also have the height, okay? Height, you can use h or you can use s, like the displacement, is 432. Okay, so in this case, we plug in, we have 0 is 48, and you plug in the right hand side, you see, minus 32, t is 0 plus c. What is c, Will? 32 times 0 is?
Oh, 0.
Yeah, so C is?
0.
Hmm?
48.
48. Yeah, C is 48. Therefore, the velocity is negative 32t plus 48. Right, everybody? And then the height. The height is the integral of the velocity. So integral of negative 32t plus 48 dt. So make sure you write the dt. dt is like your baby, okay? Don't forget your baby in the I bang, what's the integral of negative 32t? Over 32? Over, look at this. You add 1 to the exponent.
Oh, okay. 2 plus 1.
1 plus 1. 2, yes. Right. We add 1 to the exponent. When we integrate, the power always increase by 1. And then divided by the new exponent. And then plus, what's the integral of 48?
48.
T, yes. And then we plus D. Every time after you integrate, plus a constant. Okay, so this is negative 32 over 2, 16t squared plus 48t plus D. So this is the antiderivative. And then to find the D, we need to plug in the initial displacement, which is 432. Right? 432. Bless you.
Thank you.
Look at the right hand side. When you plug in 0, what happened? Now, Jay. This term is 0. This term, 0. So this equals to just D. Yeah, everybody? Okay, questions. Does that mean my C is always the initial velocity? My D is always the initial displacement? No, because if you have some function like e to the exponential function, when you plug in 0, it's not 0. This is only, the C is the initial velocity. It's only true when your acceleration is a polynomial, a power function. Okay, but if you have exponential function or like sine and cosine, I know we didn't talk about trig functions in this course, but in Applied Calc 2, you learn about trig functions. Okay, and you know cosine 0 is 1. Okay, so it's not always 0. So be careful. All right, so we can answer the first question. The height is negative 16t squared plus 48t plus 432. So far, so good, everybody? And then, second questions. When does it reach the maximum height? The maximum height, what is special about the maximum height?
Yeah, it doesn't go past it.
It doesn't go past it. And what is special about the velocity or the height? The maximum height, so what is it?
Velocity.
Yeah, velocity is 0. It kind of, the velocity is going up, and then at that moment it's 0, and then the velocity goes down. Right? So the highest, the maximum height. So we want to find t such that the velocity is 0. And we also learned about how to find maximum minimum. Do you remember you have the function to find maximum minimum, you take the derivative and find the critical point. And in this case, we want to find the maximum of the displacement. So you take the derivative, which is the velocity. Yeah, so that's why the critical point is when the velocity is 0. And our velocity is here, right? So negative 32t plus 48 is 0. How do you solve for t? Page. Subtract 48. So we get negative 32t is negative 48. And then? Yeah, divided by negative 32. So t equals what? Can you simplify? 3/2. Yes. Okay, so we get t is 3/2 seconds. Then we have the ball reach its maximum height. And then, oh, question 3. What is the maximum height? Okay, you're looking for the maximum height. So maximum height is you plot the time, which is 3/2, into the height function. Yes, everybody? This is the height at t equals 3/2 seconds. And we know we get maximum over there. So we plug in. And we plug in here. So minus 16. What's 3/2 square? Mackenzie. What's 3/2 square? Yeah, 9/4. And plus 48 times t. T is 3/2. And then plus 432. Let's calculate this. 4 and 16 cancel. We get 4, right? So we have, this is negative, what is 4 times 9? 36. And then here, 2 and 48 cancel, we get 24. What's 24 times 3? 72. Oh, do you know that 72 is 2 copies of 36? So 72 minus 36 is 36. Oh, what's 36 plus 432? 468. Yes. So this is the maximum height. Okay. And we still have some space. Let me ask you more questions. Okay. So yeah, we already answered the 3 questions. Let me ask you more. So I asked you, when will the ball hit the ground? Okay. When will the ball hit the ground? And number 5 questions. What is the velocity when it hits the ground? Okay, when it hits the ground. Okay, I can ask you 2 more questions like this. Okay, it hit the ground. What happened? Right here. What is special about this moment? It hit the ground, so height is 0. Yes. So we have the ball right here. So we find the t such that the height is 0. the height, negative 16t squared plus 48t plus 432. Right? We set this equal to 0. Can we simplify this? Yeah, I know 48 is like 3 times 16. Is 432 divisible by 16? Did you use your calculator? 432 divided by 16. What do you get? 27. Oh, so we can simplify it. Both sides divide by negative 16. Then we have t squared, and this become minus 3t, and this become minus 27. Yes, everybody? Can you solve quadratic equation? Two methods. Either factor or use the quadratic formula. Can you factor? 27. What are the factors of 27? 3 and 9, right? Well, 3 and 9, the difference give you 3? No. So we need to use quadratic formula. What's quadratic formula? What's you? Do you still remember the quadratic formula? Minus b. What is minus b here? 3. B squared. What's b squared? 9. And then minus 4a. What is a? 1. What is c? Negative 27. All over what? 2a. Everybody okay with the quadratic formula? Yes. Okay, now you see this becomes 3 plus or minus square root of 9. Minus minus become plus. What is 4 times 27? Is it 108? Yes. And then over 2. So 3 plus or minus, what's 108 plus 9? 117. Okay. Can your time be negative? Can we go backwards? No. So we only pick the positive root. Okay. Could you put this in your calculator? What do you get? Yeah. Remember the parentheses around the numerator. Gabby, do you get some number? 3.562. Do you get a number? Will?
I got 6.908.
6.908. And do you have the same answer? Okay. So this is the time it hits the ground. And then what is the velocity when it hit the ground? You're looking for the velocity. So you put the 6.908 inside the velocity. Right, everybody? So yeah, the next question is find the velocity when it hit the ground. Velocity at that time. What's velocity? Negative 32t plus 48. Right, everybody? So negative 32, negative 32t 6.908 plus 48. And what do you get? So use that answer, multiply by negative 32 and then plus 48. Let's see. Down J, do you get a number? Thank you. Feet per second. It's negative. It makes sense. Think about it. The ball goes up and hit the ground. See, it's going down. So the velocity is negative, and it's so big, right? Because you go down, oh, the velocity is faster, faster, faster. So we finish the. Okay, everybody. Yeah. All right. So this is 7.1, and we talk about antiderivatives, and we also do some problems about the antiderivatives. All right. So let's look at 7.2, substitution rule. Okay. So integral by substitution is a formal way of performing the chain rule in reverse. Do you remember this paper? We have product rule and quotient rule for derivative, and antiderivative we don't have product rule or quotient rule. Okay. Before derivative we have chain rule, right? For integral, there's something called U substitution, which is we're gonna learn now. Okay, so if you see your integral, it looks like a composite function. What do you mean by composite function? Think about all the functions we know. Power function, x to the p, exponential function, e to the ax, and 1 over x. If you see function not in this form, then it must be a composite function. Okay, everybody? For example, look at this. See? It looks like a power function, but the inner function is not x. It is a function of x, right? So this is a composite function. And like more example, like here. Do you see we don't have quotient rule, so don't use quotient rule, no quotient rule. But do you see here we have a square root? And then the things inside the square root is like the inner function. We have a composite function here. Okay, like here. Yeah, it's the quotient. We don't have quotient rule. What? Do you see we have ln x, and then this is like ln x times 1 over x. Yeah, so 1 over x is like the derivative of ln x. And like more, like here. Do you see here? We learn like e to the kx. This is not e to the kx, but it's e to the some function of x. So this is also a composite function. Okay? So I would say if you cannot solve, you cannot simplify and use this formula directly, then it must be a composite function where you can use the use substitution methods. Okay. So the idea, why do we use the use substitution methods? So this is one example. If you see something like this, based on the knowledge we have learned so far, how can we solve it? And this is a product, but we don't have product rule. Do you agree, everybody? So what do we do is simplify so you have a sum or difference. So simplify means we expand it, right? So 1 plus x squared, you remember the complete square? A plus b squared is a squared plus 2ab plus b squared, right? So it's 1 squared plus 2 times x squared plus x squared squared, which is x to the 4. This is how we expand the complete square, right? And then with the x, we distribute, so we have x times 1 is x times 2x squared is 2x cubed, x times x to the 4th is x to the 5th. See, this is the sum. Can we integrate the sum? Yes. Integral of x, increase the power by 1 divided by the new exponents, right? And then 2 stays here, x cubed integral x to the 4 over 4, x to the 5th integral x to the 6 over 6 plus c. So this example, we are able to solve with the knowledge we have known so far, okay? But what happens instead of 2, 50? If your power is 50, do you want to expand it? No, right? It takes it is very easy to make mistakes, right? You got a lot of terms. This is not doable. So that's why the use substitution methods can help us to solve this quickly. Okay, and you recognize this is a composite function. So you see, this is the inner function. Okay, and this, so if you let u be the inner function, and then this guy looks like u to the 50. Right, everybody? So it's a composite function. And then the u substitution says that let u be the inner function. And then you can find the du dx. Alright, so let u be g of x, then the du dx is g prime of x. And last time in session 6.6, we talked about differential form. So you can both sides multiply by dx. You get du is g prime of x dx. Yeah, everybody? So the O function, okay, the O function, f of g of x, and then g prime of x dx. We know g of x is u. And then g prime of x dx, see, g prime of x dx is du. Therefore, we can simplify the integral. It just becomes integral f of u du. So we get easier integral. And then we are able to integrate this easier integral using the basic formula. The three formula we have. The power rule, exponential function, and integral of 1 over x is the logarithm function. These three. Okay, everybody? All right, so let's see. How do we do this one? So we already know that we let the inner function be u. So u is 1 plus x squared. The next step is you want to find du. So put down the differential form. Du is, what's the derivative of 1? Nothing. What's the derivative of x squared? 2x. And then differential form, you also need to multiply by dx. Differential form, imagine you have two kids playing the seesaw. So you need two kids play the seesaw. Can one kid play a seesaw? No. So you need to have du and you have dx on the other side. You cannot miss one of them. Then yeah, otherwise we cannot play it. Now look at the original problem. So we know this guy is u. Your goal is to change everything in terms of u. Do you see what's left? We have x dx left. And look at this. X dx. How do you get rid of the 2? Divide it. We solve for x dx. And that is 1/2 du. Good. Now we have the x dx is 1/2 du, and put the du at the end, okay? And then this is, the other one is u to the 50. Is that clear, everybody? Yeah, x dx is 1/2 du, and don't put the du in front of the u to the 50. The du must be at the end. Now, this is a simpler integral. Constant multiple stays here. What's the integral of u to the 50? 51 over 51. Exactly. After you use the u substitution, you get a simpler integral where you know the formula for the antiderivative. Yeah. Okay. So, and then plus c, sorry. Therefore, this is 1 over 2 times 51 is 102. Put the x back. So u is 1 plus x squared. to the 51 plus C. This is the final answer. Okay, so we don't need to extend this. Okay? We just use substitution, make a change of the variable, so we get a simpler integral. We can use the antiderivative formula directly, and then plug the x back. Okay, so have a good weekend. Your homework 10 is due tonight. So submit your first attempts, and then you can continue to work on the problems to increase your scores. And make the exam correction and wrapper. If you haven't submitted the practice exam, also submit that. Bye.